Hi again. Okay, in this video I'm going to talk to you a bit about strategy for working on natural deduction problems. So once you get the general idea of what a natural deduction proof is supposed to be, right, we start from your premises and chain together a bunch of little steps following the rules to get to the conclusion. That shows the argument's valid. And even once you've memorized all the different rules, you may still feel overwhelmed when you see an actual problem and think there are all these rules to choose from. How do I decide which one to do first? How do I get from these premises to that conclusion? I'm going to offer you a strategy. This is not something you absolutely have to follow. There are other strategies. Often there's more than one right answer, but this is the strategy I use. I recommend it to you wholeheartedly. I hope you'll use it and find it helpful. This is going to help you narrow down which rules to use at which stage. This strategy is going to work for pretty much every problem I assign you. The structure of the strategy is I'll say there's a plan A, a plan B, a plan C. You do plan A if you can. If you can't do that, do plan B. If you can't do that, do plan C. There is no plan D. Each of these plans, if you can apply it, is going to tell you, here's the rule to use. When you use it, you'll write down something new. And the rest of my strategy says, as soon as you write down something new, we start the process over again. We go look at the extra things we've written. That changes the problem. Where we again say, plan A if I can, otherwise plan B, otherwise plan C. Now, here's what the plans are. I'll tell you what they are in general, and then we'll work through a couple of examples to see some refinements and exceptions and see how to put them in practice. So plan A says, start at the bottom, look at your conclusion, try to work backward. And while you're working backward, you're going to do that using an introduction rule. So remember, most of our rules come in these pairs of introduction and elimination rules. Either all or almost all of the connectives in TFL have both an introduction and an elimination rule. All or almost all depends on which version of the textbook you have. There's at least one rule that could be called one thing or the other. It's a fuzzy case. Okay, plan B, if we can't or don't want to work backward with an intro rule, plan B is work forward using an elimination rule. Okay, remember the idea behind, generally speaking, an elimination rule starts with some sentence that has the connective in question as its main connective. So and elimination starts with an and sentence, or elimination starts with an or sentence, and so on. Starts with a sentence that has the connective and gets you to a sentence that doesn't. Okay, so similarly, an introduction rule takes you from sentences that don't have the connection in question and then adds one in. So it takes you from some sentences that say don't have an arrow, or maybe have some arrows, but then gets you to a sentence that does have arrow or has an extra arrow in it. Arrow is introduced as you read it forward. So if we're going to work forwards with elimination rules, from the top, work forwards with elimination rules, starting with things that have connectives, get to things that lack them. And we work backwards with introduction rules, so start at the bottom, take this thing backwards. If an introduction rule starts with simple sentences and goes to complicated ones that have more connectives, and we do that backwards, then you're going from complicated sentences with the connective to simpler sentences without them. So if we do both of these things, then you wind up with a proof, a derivation that has the shape of starting with complex sentences, breaking them down into their parts so they get simpler in the middle, and then we use introduction rules to put those things back together, and then we get something complicated again at the end. That's kind of the shape of how we're going to go. Okay, about 90%, I'm making that number up, but a lot of the problems I'm going to assign you, plan A and plan B are going to be enough. Sometimes you'll get stuck though, and you won't really see how to use either of these plans. And then we have a safety net rule that'll kind of bail you out. I'm going to say use this rule called IP, indirect proof. Okay, we'll talk about that rule when we get there. Let me give you a specific problem that we'll work on, and we'll see the plans in action. Okay, so Here's, suppose I've told you, give me a natural deduction proof or a derivation to show that the following argument is valid. It's got three premises. First premise, A and B arrow R. Second premise, A. Third premise, C arrow not R. Okay, those are our premises, 1, 2, 3. And the conclusion we want to get to is not C and B. Okay, that's our problem. First thing, whenever you're setting up one of these problems, give yourself space. Draw a big vertical line with your premises at the top, horizontal line underneath them, bunch of empty space to work in, and your conclusion at the bottom. Okay. Always, we want to do plan A if we can. Plan A says work backwards with an introduction rule. If we're working backwards, that means the first place I look is at the bottom to see what I'm working backwards from. The plan says use an intro rule, but it doesn't say which one. How do I know which introduction rule I'm going to use? There's an easy answer. Look at the conclusion you're trying to get, look at your goal, and check its main connective. So in this case, we have a sentence that's got two connectives in it. There's a not and there's an and. But the negation is the main connective. Generally speaking, our rules just care about the main connective. So if you remember some of our introduction rules, and introduction looks like this. If I wanted to use and introduction to get some line, I'm going to wind up with something whose main connective is and. I'm not going to wind up with something like this that has not as its main connective. Whenever you're using an intro rule working backwards, it's going to be the rule for the main connective of the sentence you're trying to get. So plan A tells me I'm going to work backwards here with an introduction rule. Which one? Has to be negation introduction, because that's the main connective of the goal I'm trying to get. Negation introduction, you can then either you remember it or you go look it up. The negation rule, negation introduction rule says if you're trying to get something not A, remember scripty A is like a blank, it could be anything. In this case, our A is going to be C and B. If I want to get not A by not introduction, the rule says I need a subproof that starts with A and ends with a contradiction. So in my case, since I've put C and B in the A gap here, that means that also has to be the thing that starts my subproof. So I know I'm using this rule. This is going to be my final step. Final because I'm working backwards from the very bottom. If I'm going to use this rule, I need to say that I have the thing the rule demands. The rule demands a subproof starting with C and B. That's something I'm temporarily assuming. That's what this vertical line does. And I'm going to do some steps and eventually get down to a contradiction sign. That's what this rule wants. So that's what I decide I'm going to give. My next step is to figure out how to fill that out. Okay, I've just applied plan A. Plan A said, use the introduction rule, working backwards. I've written down new things. Effectively now I have a new problem. Before my problem was get from 1, 2, and 3 down to this. Now my problem is get from 1, 2, 3, and this extra assumption to this. I can forget about what happens afterwards. As long as I can get here, I know the rest of the story. The rest of the story is negation introduction. So I can forget about that now. I basically have a new problem. I need to get a contradiction sign from these things. So I start the process over. I say plan A if I can, otherwise plan B. Plan A, remember, says look at your goal, check its main connective. In this case, you can think of the contradiction sign as a connective. It's got introduction and elimination rules, depending on your version of the textbook. We could use contradiction introduction, also called negation elimination, working backwards. This is kind of a twilight zone somewhere in between plan A and plan B, because this rule gets called introduction, gets called elimination. Think of it whichever way you like. I think it makes sense to think of this as a case where we're going on to plan B. let's go to plan B. So this is your first exception to your plan A. If your goal is a contradiction, then maybe instead of working backwards with the introduction rule, work forwards with elimination rules, because that's what plan B says. So plan B says, look at the lines you already have, the things that you've already learned or assumed, and try to work forward from them using an elimination. Okay, which elimination rule? The way we choose is just like when we were working backwards in plan A. The only elimination rules you're going to be able to use are the ones for the main connective of the sentences you have. I can't do and elimination on this, even though it has an and in it, because that's not the main connective. And elimination, if you're looking at the statement of the rule, the definition in the textbook, it says, suppose you have a sentence like this, then you can get A or B. But there's no way to fill in the A blank and the B blank to get this, because bracket A, that's not a sentence. B bracket arrow R, that's not a sentence, so it can't go in this gap. The only elimination rule I'm going to be able to apply if I'm trying to do an elimination rule on that line 1 is arrow elimination, because that's the main connective. R. I remember what was there. Okay. So that still leaves me with some options, right? I have more options than with plan A. Plan A, I only had one thing to work backward from. Here I've got 1, 2, 3, 4 things. I could do an elimination rule. I could do arrow elimination here, arrow elimination here, and elimination here. You notice I skipped this one because it's atomic. It doesn't have a connective. There's nothing to eliminate. This is another one of your exceptions to plan A. If you have a goal that's atomic, there's no way to get it with an intro rule. So you can't use plan A. Likewise, I can't apply an elimination rule to this thing by itself. Okay, so what do I want to do an elimination rule on? I could do whatever I like. Well, let's see. Start with line 1. It's first. Let's see if we could do arrow elimination there. I'm going to go look up my arrow elimination rule. It looks like this. You need an arrow sentence, and you need to have the antecedent of that sentence, and then you can get the consequent. That means if I want to do arrow elimination on here, so if this is going to be my arrow sentence, then in this blank I'm putting A and B. That means arrow elimination, if I want to get R from this sentence by arrow elimination, I need to have A and B. That's what would go in here. I don't have that yet. So I can't do arrow elimination on this unless I can get B. Likewise, if I want to do arrow elimination here, I would need to have C if I wanted to fit this sentence into this pattern. I don't have that. What about here? C and B. We just saw the and elimination rule. It looks like this. And elimination, unlike arrow elimination, just needs the one line. If I've got C and B, I can get C in one step. So why don't we do that one? So I say C, that's a new line I've put down. I'm getting that by this rule and elimination. And I'm applying that rule to line 4. And elimination just needs one line, so I only list the one line. That's fine. Okay. We've written down a new thing, so in principle, we start the process over again. We're still not doing plan A because our goal is the same thing it was before. I'm as stuck as I was before. But I have new things that I can do plan B on. This is an atomic sentence, so I can't do an elimination rule on it by itself. But remember, if I want to do arrow elimination on this arrow sentence, I would need to have C, which is what I just got. So now I can do arrow elimination. So if I'm doing arrow elimination on here, then I'm plugging C into the A gap. That's why this is okay. And I'm putting not R in the B gap. So that's what I'm going to be able to get. Not R. That's by arrow elimination on 3, and 5. Okay. What about if I wanted to do the same thing for this arrow sentence? I said I couldn't do arrow elimination on line 1 because I don't have A and B. But what if I could get that? That might be promising, right? If I had A and B, it's hard to tell because my whiteboard is very small, so I'm a little compressed, but I'm imagining there's extra space in here. I'm going to fill that in eventually. I'll just put ... so you can remember. I'm putting this in as a new goal. I'm saying, imagine I could get this. If I could fill in somehow how to get this, then I would have the extra ingredient I need in order to get R from line 1 by arrow elimination. Why did I put that down now? Well, partly just because I want to be able to do an arrow elimination on there. It's nice to do eliminations, but also I remember if I want to get this contradiction, and don't forget that's where I'm trying to get, I need some sentence and its negation. I just got not R. If I can get R, then I'll be done. This is what I've got in mind here is this rule that says if you want to get a contradiction, get some sentence and its negation. That rule is called either negation elimination or contradiction introduction. Depending on your version of the textbook, you can think of it either way. This is sort of halfway in between plan A and plan B. Once I've got a negation, maybe I think, how do I eliminate this with an elimination rule? Well, it's going to be an elimination rule that combines with the opposite. So not R, R, and what it gets me is a contradiction. Or I could think I'm working backwards from the contradiction. That's the deal. Contradictions can be a little bit confusing just because this rule doesn't tell you what these two sentences have to be. Any sentence and its negation is enough to get you a contradiction. Okay, so let's come back to where we were. I'm saying if I can get A and B, ... up here to remind me this is a new goal. If I can get A and B, then that will be enough to combine with line 1 to get me R by arrow elimination. And now I've decided if I can get R, then since I have not R, that would get me a contradiction by negation elimination. So everything from A and B down is filled in. I know what rule I would use to get this. I know what rule I would use to get this. I know what rule I would use to get this. So I just need to think about how to get that. So now I'm in a situation where this is my goal, A and B. We've got new things. We start the process over again. Plan A if I can, right? Plan A says introduction rule working backwards. Which introduction rule? Has to be the introduction rule for the main connective. The main connective is and. So I'm thinking and introduction working backwards. And introduction says if you want to get A and B, you need to have A and B. I have A already. If I can get B, then I'll be done. So I put that in as a new goal. Now my goal is B. Where can I get B? I can't get it by an introduction rule working backwards because it's atomic. So I go to plan B. Can I get it by an elimination rule working forwards from anywhere? Well, when you're trying to pick a line to do an elimination rule on, maybe you get a little confused now because there's a whole bunch of lines and I don't remember which ones I've done and which ones I haven't. You might look for ones that have something that looks like your goal. Where do I see a B up here? Only there. Maybe I want to do an elimination rule on this line. Plan B, it's got my goal in it. If I'm doing an elimination rule on here, there's only one option, the one for the main connective, and. If I'm doing and elimination, there are two versions of and elimination. The thing on the left, the thing on the right. In this case, I'm interested in that thing on the right. I can get B over here by and elimination on line 4. And now it looks like I have all the things I need. I just need to fill in line numbers for these things down here. I didn't fill them in before because I didn't know what number all the lines were going to be, but now I can tell. Okay. Remember, here's how you check whether your proof is done. Go through every line, every single line, from 1 to 11 in this case, needs to either be a premise or a temporary assumption that starts a subproof, or it needs to have a rule beside it with the right number of lines cited, the right number of lines for that rule. So, and elimination 4, that's fine. Arrow elimination, that needs to cite 2 things, 3 and 5, that's fine. And elimination on 4, still fine. And introduction, I need to cite 2 things. Which 2? A line with A and a line with B. I have an A on 2, a B on 7. So 2, 7. Arrow elimination, I've only cited 1 line. That's not enough. Arrow elimination needs 2 lines. So arrow elimination line 1, here's your A, arrow B. Now I need to find A and B somewhere. That's on line 8. 1, 8. Negation elimination, I need to list 2 lines now. I need some sentence and its negation. I remember I was doing R and not R. If you ever get lost here, by the way, almost always any line is going to cite the line right before it, because usually you got that line so you could get this one. So I might think, well, I'm doing line 9, that's got an R. Now I need to find not R somewhere. There it is, line 6. I hope the microphone isn't picking up my stomach growling. It's very unprofessional. Finally, negation introduction. That's supposed to cite a subproof that starts by assuming C and B and ends with a contradiction. So that is 4 through 10. And now we're finished. That all came from chaining together Plan A and Plan B, introduction and elimination rules. Okay, I said I would come back and give you some refinements on the strategies. These are the basic ones, though. Here are some exceptions I'm going to give you. We've run into 1 already, or maybe you call it 2. If we're looking at Plan A, so you're looking at your goal and checking its main connective. If your goal is a contradiction, then maybe you're not going to use Plan A working backwards because, well, the introduction rule for that thing is kind of like an elimination rule. One version of the textbook calls it an elimination rule. It's a little weird. More practically speaking, the rule doesn't tell you what it needs. There are many different ways to satisfy the rule. Just knowing that you're getting a contradiction doesn't tell you which sentence and its negation you're going to get. So I'm going to list exceptions here. So if your goal is a contradiction, the other exception, if your goal is atomic, then there's nothing to introduce. You can't use an introduction rule going backwards. So that's when you would go down to Plan B. The other exception I'll give you, we haven't actually encountered yet. When the main connective of your goal is OR, I want you to be very cautious about working backwards with OR introduction. The reason why is the way OR introduction is a very simple rule, but sometimes if you use OR introduction working backwards to give yourself a new goal, you'll wind up with a goal that you can't actually get. So you might have an argument whose conclusion is A or B, and the argument with whatever premises it has is valid. But if I work backwards using OR intro says, if I want to get this OR sentence, it's enough for me to have A or B, either one. So maybe I write A in as a new goal working backwards. But this argument might not be valid. The problem is this sentence A, that says a lot more than this does. This OR sentence just says one or the other or both of these sentences are true. I don't know which one, at least one. Right? When we were talking about Alfred and whether he studied, I said, I don't know whether he studied or he didn't, but I know at least one of them is true. Exactly one of them, in fact. But if I put A here, in this case, or if I put B, I've said much more than this, and there might not be enough information in my premises to tell me this is true. We'll come back to this. I'll give you an example that uses this. Okay. That's an exception to Plan A. I'm not going to give you exceptions to Plan B, but I am going to suggest an order to do elimination rules in. I'm going to say, when you're doing elimination rules working forwards, so when using introduction rules working backwards, I said, be very careful about using or introduction. The reverse is true for using Plan B, working forwards with elimination rules. I think your top priority, if you have an or sentence, do or elimination first. We'll see the reason why in practice. Effectively, or elimination. So I think I have had many students in the past who have found the or elimination rule confusing, and so they try to put off using it. I think that's the wrong thing to do. Very often, your proof is going to be simpler and shorter and easier if you do or elimination first. If you do other things first, you're going to have to repeat yourself and you might just get stuck. If or elimination is confusing, let's run towards the dangerous thing and try to get to grips with it. You will be much better. You're not going to be able to avoid this rule. It's in there for a reason. Okay. Do or if you can. I think that's it for now. Maybe I'll suggest this. Put off doing negation elimination, trying to get a contradiction until you've done other things. Just because, like I've been saying, that rule doesn't tell you exactly what you need to get. So it's a good idea to work with everything else until you get an idea of how you're going to be able to complete that thing. So plan A has exceptions. You might not want to use plan A if your goal is a contradiction. You can't use it if your goal is atomic. You should be very, very cautious about using plan A if your goal is a disjunction, an or sentence. With plan B, I'm not giving you exceptions, but priorities. So top priority, or elimination. Middle priority, everything else. Lowest priority, contradiction, or negation, elimination. Okay? Let's practice a little bit with or elimination. So say we have this problem. We've got just one premise this time. Premise is A and B or C and D. And the goal we're going to try and get to is B or C. Okay? As always, we start out plan A. Plan A, look at the conclusion, check its main connective. What is its main connective? In this case, it's or, so that, I say, means we should be cautious. Don't use or introduction unless you're sure you can get it. The silly mnemonic I give people sometimes, it's really dumb, but hopefully that's how you remember it, is you think of those, the or sign, think of that as little devil horns. Don't trust the or. But then when you get to plan B, your first priority should be to eliminate that thing. It's stupid, but I like it. Okay. Or is the devil, I'm not using plan A, I don't trust that thing. We go to plan B. Plan B says elimination rule. In this case, I've only got one sentence I could apply an elimination rule to. But even if I had choices, I would want to eliminate this one first because it's an or sentence. Okay. So I know I'm doing or elimination on this line. Here's your or elimination rule. The rule says, suppose you have some or sentence. You can get any old sentence. This doesn't have to be the same as anything that's shown up in your or sentence, as long as you can complete the following two subproofs. Or elimination requires an or sentence and two subproofs. First subproof, I assume A. Second subproof, I assume B. And I want to show that C is true either way. That's or elimination. The general idea is this or sentence tells me one or the other or both of these things is true. I don't know which one, but it's got to be one of them. If I can show that some sentence, any old sentence, is true either way, then I know it's true. Period. That's the idea. In practice, you might look at this rule in the definition and say, how am I going to know what sentence to put down here? It doesn't tell me what I'm allowed to put. Well, you're allowed to put anything as long as you can complete these subproofs. In practice, so if I'm allowed to put anything, I might as well put the thing I want to get. Okay, here's what we do in practice. In plan B, once you decide I'm doing an or elimination, I say, well, that rule needs not just the or sentence, but two subproofs. So let me open up two subproofs. just divide the space I have available in half. So, yeah. The OR elimination rule tells me how each subproof has to start. One of them has to start with the left disjunct. One of them has to start with the right disjunct. So in this case, my disjuncts are A and B, C and D. So I need a subproof starting with A and B. I need a subproof starting with C and D. How do those subproofs have to end? They have to end the same. The rule doesn't tell me how they have to end, just as long as it's the same thing, as long as I've got the same thing in both places. I'm going to put in the thing I want to get. So I'll put B or C at the end of both. And I'm going to say this line down here, the very last line of my proof, that's what I'm going to get by my OR elimination. I'm going to put in 1 now. So OR elimination needs me to cite 3 things. The OR sentence, the first subproof, the second subproof. I don't know what the numbers on the subproofs are yet, but I do know where the OR sentence is. I'm going to write that in now. I'll fill in the rest of the numbers later. Okay, we've applied plan B. We can start over again. I don't need to worry about this line anymore. I have 2 new sub-goals. Let's pick one of them and work on it first, and then we'll do the other one. If I can get from here to here, and from here to here, then I'll be done. So let's do the first one first. My goal now is B or C. Let's be extra cautious. Plan A was work backwards with an intro rule, but I don't trust OR, because it's the devil. So I'm not going to work backwards with an OR introduction, unless I feel extra confident. But I'm a sheepish kind of person. So I'm going to go to plan B. Plan B says, elimination rule, working forwards. I've got 2 different lines that I could, in principle, hit with an elimination rule. But I've already done OR elimination on this one. I could do that again. There's no rule that says I can't do that again. But then I'm just going to open up the same 2 subproofs I did before. Let's try the other one. And elimination. That's nice. And elimination says, when you have an and sentence, you can write down either conjunct. If I have a conjunction, I can write down either conjunct after that. This sentence tells me both A and B are true. So A is true. So B is true. Which one do I want? I've got a B here. Why didn't I get B? So I'll say I'm getting B by and elimination on 2. Now I restart everything, plan A working backwards if I can. I feel more confident now. If I'm using OR introduction working backwards, remember OR introduction says if you've got B, that's enough. If you've got C, that's enough. Well, I have one of those things. The reason why we're cautious with OR introduction working backwards is we want to make sure we don't wind up with a new goal that I can't get. Well, I know I can get B because I already have it. So line 4, we're going to get that by OR intro on 3. So that subproof is done now. I can forget about it. In fact, I have to forget about it because everything that happens in here depends on this temporary assumption. And because this vertical line has ended, that means I'm no longer assuming that anymore. When I'm working down here in this subproof, or down here below it, I can't cite any single line inside there. I'm allowed to have a rule like OR elimination that cites the subproof as a whole, right? If I'm citing the fact that you can get from here to there, that's fine. But I can't cite, let's say, B. I couldn't do like OR introduction here on line. I can't just copy this citation down here because that is gone. That depended on this temporary assumption when I'm working down here. I'm not assuming it anymore. Okay, so now I have to get from line 1 and line 5 down to B or C. Start the process over again. Plan A, working backwards if we can. Maybe I feel confident now. Maybe this time I feel more confident. And I think I can get one of these things. I'm going to say I'm getting this by OR intro working backwards. OR intro, there's 2 versions of it. If I get B, that's enough. If I get C, that's enough. But I think this time I can get C. So I'll put that in as a goal. Maybe I'm not that confident. Maybe I'll write it in pencil. Or in this case, dry erase marker. If it turns out that I can't get this thing after all, I'll erase it and come back. But I think I can get C. So, I've written down something new, start the process over again. Plan A, look at your goal. My goal is C. I can't use plan A working backwards because this is atomic. There's nothing to introduce. So I go to plan B. Use an elimination rule working forwards. There are 2 lines available to me at this point. This one I've already done the elimination rule on. Not interesting. This one I haven't done an elimination rule on yet. It's an and sentence, and elimination lets me get either C or D. C is exactly the thing I want, so we're all done. I'll say line 6 is C by and elimination on line 5. All I have to do now is fill in line numbers, and we are complete. So this is 7, this is 8. This was or introduction on the line with the C, that's 6. Now for or elimination, I need to cite those 3 things. The or sentence I've already cited. Now I need to find a subproof that starts with A and B and ends with B or C. That looks like 2 to 4. And then a subproof that starts with C and D, ends with the same thing. That's 5 to 7. There you go. That's plan A and plan B chained together a bunch of times with some exceptions and priorities. I haven't talked to you about plan C yet. I'm just going to tell you what that is. If you find yourself getting stuck and plan A and plan B haven't worked, here's what the indirect proof rule looks like. Suppose your goal is A. Doesn't matter what it is, just whatever sentence it is. If you use indirect proof, working backwards, what that does is give you an extra temporary assumption and a different goal. So indirect proof says you can get A as long as you have a subproof that starts with not A and ends with a contradiction. What's the advantage of doing this? Well, you've got a new thing that you can do rules on, right? You've got a new thing that you can apply stuff to. Maybe before this you had something like an arrow sentence that could use this to get B. You've got a new available line. Maybe, in fact, you had, well, no, that wouldn't make sense. It can help. I'll leave it at that. You'll run into it at some point, but once you've done this, you'll have a new thing that you can do plan A and plan B on, and chaining these things together is going to solve all your problems, or all my problems that I've assigned to you, which are then your problem. I'm going to stop talking now.